The last thing that we're going to learn to draw today is something called an orthographic drawing. And an orthographic drawing is used by industry and used in the actual creation and CAD drawings for buildings and blueprints and all of these kinds of things, so that you can tell exactly where sides need to meet together and so forth. So an orthographic drawing gives a two-dimensional representation of a 3D object and displays what it's going to look like when it's viewed directly from the top, from the side, and from the right side. So instead of actually drawing one drawing, you're drawing three different drawings that spatially represent the front, the top, and the right side view. So this is what a rectangular prism is going to look like in an orthographic drawing. That's what we're going to draw in just a moment. It's drawn on a piece of graph paper like you have before in front of you, so all the corners come together at right angles, unlike with the isometric things where they're all rotated off slightly to one angle. Okay, so you always again need to state the scale or the dimensions of each side of the object that you're actually drawing. So let's go through and let's identify what we need to draw. So in order to create an orthographic drawing, you got to complete an individual scale drawing of each of the top, the front, and the right side views. So three different drawings. Now these three drawings, they have to be oriented in such a way that you can see the edges all line up. Okay, and so I'm going to show that to you in the example above. So we're going to try and draw our 3 by 4 by 2 rectangular prism in an orthographic manner in the space above. So again, 3 meters wide, 4 meters high, and 2 meters deep on the front hand side. Okay, so I wanted to quickly draw 3 meters wide. So 3 meters wide, this is going to be my front view over here. So I'm going to go 1, 2, 3 meters wide, and it's going to be 4 meters high. So 1, 2, 3, 4. So I'm now drawing in. Okay, so that's going to represent my front view. So this is my front view. Now what I need to do is draw my top view. Okay, and so my top view is going to be, again, 3 meters wide, but in this case, so my top view is going to be 3 meters wide. So oh dear. My top view will be 3 meters wide. 1, 2, 3. However, my width or my depth is only 2 meters. So I'm going to draw it by 2. So if I was looking down on this object, it would look like this. Okay. So this actually represents my top view. Okay. And now what I need to do is I have to draw my front view. So in order to draw my front view, I again need to recognize that this is going to be, and my front view is going to be 4 meters high and 2 meters deep. So my 4 meters high is right here. My 2 meters deep is right here. So I close that off. And I'm just going to fill that in. So 1, 2, 3, 4. So that actually is going to represent my right side view. So my right side view. Okay, so you can see how these three things actually fit together. So this as my front. Okay, if I rotate this down, then I can see the top. So it gives me the same. You'll notice that the distance here is the same for both the front view and the top view. Okay. You'll notice also that the width between my top view and my side view is the same. So my width here is both 2. Okay, and so those edges go together. And then again, my height is the same for both my for both my front view and my right side view. Okay, so what an orthographic drawing allows you to do is see the three-dimensional image as a collection of three independent two-dimensional images whose edges will all fit together. Okay, so if you rotate it completely flush with your perspective and all you see is a straight top-down, straight front view, or straight right side view, this is what your object is going to look like.